Alright guys, good evening and welcome back to Electric Circuits. So in the last session we have completed mesh analysis and also introduced you to our first network theorem, which is the principle of superposition. And this superposition, it can be applied to any linear network or linear circuit driven by two or more independent sources. Okay, and you know how to identify if any given network is what, linear or not. And if at all it is linear, we can always use superposition. See, you have to use superposition only when you feel that using superposition will make the analysis easier. So just because you can use superposition does not mean you should always use what, superposition. In fact, in this course, we'll study what several approaches to circuit analysis. So for a given circuit, you can always do the analysis in multiple ways or using multiple approaches, but always there will be one approach that will be the best suited for that particular circuit. Okay, so through enough practice, observation, and also by getting some experience, you should be able to judge for the given circuit which is the best way to do the analysis. But the bottom line is whatever be the approach, ultimately it is based on what, the application of KCL and KVL. Yes. So this course, as I already said in the beginning, is entirely based on what, the application of KCL and KVL. So whatever be the approach, that approach will be based on what, KCL and KVL. Okay, so you should be very comfortable writing down KCL and KVL for any given circuit. Okay. So this is lecture 5. Today is 18th. I think towards the end of the last session, we also took up one example related to what, superposition. Okay, so for this circuit, there are two sources, right, Vs and Is, and we can perform two separate experiments or we can write down two separate cases. In each case, we find the value of I0, and in the end, we just add the two values of I0 to get the net value of I0. Okay. So initially in this session, we'll look at a few examples wherein we can use this superposition. Okay. And then we'll move on to other things. So look at this circuit. So this is what the given circuit, and the question is what, to find Ix. Ix is what, the current through this 2 ohm resistor using what, superposition. So the fact of the matter is what, you can also find Ix without using superposition. Maybe you can directly do mesh analysis or something. Yes, but here the question is what, to find Ix using superposition. Okay, so clearly it is what, a linear circuit, because apart from the independent sources, what elements are there? The 2 ohm resistor which is linear, 1 ohm resistor which is linear, and then this dependent source, what is its value? 2Ix. So what is the controlling variable of this Ix, and how does it depend on the controlling variable? Is it not Ix power 1? So definitely it is what, a linear circuit, because apart from the independent sources, the rest of the elements are all linear. Okay, and how many independent sources are driving this circuit? Two independent sources, one voltage source, another current source, and I told you what, these independent sources will act as what, inputs. So this is like x1, this is like x2, and whatever we are supposed to find, in this case we have to find what, Ix. So this Ix is like the output. So this output will definitely be what? K times x1, I mean some k1 times x1 plus k2 times x2, okay. Anyway, with all this background, let us use superposition, okay. So superposition is very simple. So we have to write two cases since we have two independent sources, okay. So in the first case, let's say the 10 volt source is what active and the 3 ampere current source, let's make it 0, okay. And what will the circuit be? Ten volts, 2 ohms, 3 ampere current source. When you make it 0, it becomes what? An open circuit. This is what the 1 ohm resistor. I told you what, in every experiment or in every case, every dependent source will remain as it is, okay. So this will continue to remain, that is what, 2 Ix. The question itself is what? To find Ix, right? Let Ix in the first case be some Ix prime, okay, Ix prime. So this is also what, or Ix1, because this case 1, I will call it what? Ix1. So then this value also will become what? 2 times Ix1, okay. That's all. Now we have to find what? Ix1. When the current source becomes open, does it not become a single loop circuit? Because the current in this branch will be 0. So the current through 1 ohm will also be the same Ix1. So all elements are in series around what? A single loop. So what is the drop across 2 ohms to Ix1? What is the drop across 1 ohm? It is 1 times Ix1. So let us write KVL around this loop starting from this point. So writing KVL will give us what? Minus 10 plus 2 Ix1 plus again Ix1 plus 2 Ix1 equal to what? 0. 5 Ix1 equal to what? 10. Ix1 equal to what? 2 amps. So the value of Ix1, it is what? 2 amps. So this is what? The value of Ix due to the 10 volt source alone. So if at all only the 10 volt source is present, then the value of Ix is what? 2 amperes, okay. In the same way, we must write the other case, and in the other case, the 10 volt source, you have to make it what? 0. And this time the 3 ampere current source, it is going to be what? Active, okay. The circuit itself, when you make the 10 volt source 0, it becomes what? A short circuit. So 10 volt source on the left side, it has become what? A short circuit. Then we have the 2 ohm resistor. And this time the 3 ampere current source is going to be present. This is what? 1 ohm. This is what? Like 2 Ix. So in case 2, let us call the value of Ix as what? Some Ix2. Then this is also what? Ix2, okay. Okay. Now what is this current? It is what? 3 amps. Now if you look at this particular point, at this point Ix2 is what? Entering, 3 is also what? Entering. So what will this current be? Will it not be 3 plus, Ix2 KCL? So what is the drop across this? 1 times the current. What is the drop across this? 2 times Ix2. Now let us write KVL around this outer perimeter of this circuit, okay. So writing KVL will give us what? 2 times Ix2, yes or no? 2 times Ix2 plus 1 times this current, which is what the current itself, 3 plus Ix2, and then 2 Ix2 equal to what, 0. So 2 plus 1 plus 2 is what, 5 Ix2 equal to what, minus 3. So what is Ix2? It is minus 3 by 5, which is minus 0.6, amps. So what is this minus 0.6 amperes? It is the value of Ix due to the 3 ampere current source, okay. But in the actual circuit, both the sources are going to be present or active at the same time. So what is the net value of Ix? So the net value of Ix will be what, Ix1 plus Ix2, which is 2 minus 0.6 or 1.4 amperes, okay, correct, Kanan, it is 1.4 amperes, okay. So this is how we do our circuit analysis using, okay, 7 by 5, that's also correct, using superposition. So here we have to understand that during every case, the dependent source will remain as it is. You don't have to make the dependent source 0 or anything, okay. Another important point is what? Superposition can be used, of course, in a linear circuit for finding what the net voltage or net current. But superposition cannot be, should not be used for directly for finding what power absorbed by any element or power supplied by any element. So the point is what? For power calculations, you do not use superposition directly. So I'll try to illustrate this point through an example, okay. So let's say we have what, a simple circuit. Three volts, 6 ohms. This is what, a 9 ohm resistor. Let the current through 9 ohms be some I. Let this be another current source of value 2 amperes, okay. Let's say we want to find I, okay, in this given circuit. Let's say we want to find I. Clearly it is what, a linear circuit, because apart from the independent sources, we just have 2 resistors, both of which are linear. And since there are 2 independent sources, one voltage source, one current source, we can use superposition, okay. And what is it that we want to find? I, that is the current through the 9 ohm resistor, okay. So case 1 is what, the 3 volt source is active and the 2 ampere current source, it becomes what, 0. Yes. So when the 2 ampere current source becomes 0, it just becomes what, an open circuit like this. And then let's say the current in this case 1 be some I1. Now when the current source becomes 0, the current in this current source branch will become 0. Now there is what, a loop. Yes. Even this current will be what, I1. So loop current will be what, loop voltage divided by net resistance in the loop. 3 volts divided by 6 ohm plus 9 ohm. 3 by 15 is what, 1 by 5, which is 0.2 amps, okay. So what is the power dissipated by the 9 ohm resistor in this case? The power dissipated by the 9 ohm resistor in this case will be what? I1 square into 9 ohm. Yes, I1 square is what, like 0.2 square, which is 0.04 into 9, and that is 0.36 watts. Okay. Anyway, this is what the first case. In the second case, the 2 ampere current source is going to be active, whereas the 3 volt source, it is going to be inactive or 0. Okay. So what will the circuit be for this case? 2 ampere current source active, but the 3 volt source, it becomes what? 0. That means this voltage source, it becomes what? 0. Okay. What will happen? I mean, let's say the current in this case is what? Some I2. So what is this current? It is what? Some 2 amperes. Okay. So what will happen to this current? Now 6 ohm and 9 ohm clearly are in parallel, right? 6 ohm and 9 ohm are in parallel. In fact, the 6 ohm resistor, the 9 ohm resistor, and the 2 ampere current source all are in parallel. Why? This entire thing is what? One node. This entire thing is what? Another node. So all elements are connected between what? The same 2 nodes. So clearly all elements are in parallel. So if you have 2 resistors in parallel across current source, you know what takes place? Current division will take place. So this 2 amperes will get divided between 6 ohm and 9 ohm. And you also know that when you have only 2 resistors in parallel, you have a result. So the current through 9 ohms will be directly proportional to what? The other resistance. First you write down which current is getting divided. It is what? 2 amperes into 6 ohm by 6 ohm plus 9 ohm. So 2 into 6 is what? 12. 12 by 15. 12 by 15 is what? 4 by 5, which is 0.8 amps. Okay. Let us also find the power dissipated by the 9 ohm resistor in the second case. We will call that power as what? P2. Okay. And it will be what? I2 squared into 9 ohms. So 0.64 into 9. What is 0.64 into 9? 0.64 into 9 is what? 5.76 watts. So what is this 5.76 watts? In this circuit, if only the 2 ampere current source is present, then the power dissipated by 9 ohms is what? 5.76 watts. And earlier we found some power, it is what? 0.36 watts. So in this circuit, if only the 3 volt source is present, then the power dissipated by the 9 ohm resistor is what? 0.36 watts. But what is the net current flowing through the 9 ohm resistor? The net current flowing through the 9 ohm resistor is what? Sum of the individual currents, that is what? I1 plus I2. So is it not 0.2 plus 0.8, which is actually what? 1 ampere? Yes. So when both the sources are present, that is in the original circuit, the actual current through the 9 ohm resistor is what? 1 ampere. Okay. So what is the actual power dissipated by the 9 ohm resistor? It will be what? The square of the actual current into the 9 ohm resistor. I is what? 1 ampere. 1 square into 9 is what? 9 watts. But if you add the individual powers, that is what? P1 plus P2, 5.76 plus 0.36 will be what? 6.12 or something, which is not the same as the actual power dissipated by the 9 ohm resistor. So this is not equal to P1 plus P2. So this is the point I was trying to make earlier. So for power calculations, do not use superposition directly. Yes, you can always use superposition to find the net voltage or the net current. And from the net voltage or net current, you find the power or you do the power calculation. But do not find the individual powers and try to add the individual powers and say that it is what? The net power. Okay, that is incorrect. Why? Because how does power depend on the current or the voltage? Power is proportional to what? Square of current. Power is also proportional to what? Square of voltage. So because of the square dependence of the power on the voltage or on the current, we cannot use superposition directly for power calculations. Okay. So do not use superposition for power calculations directly. Okay. So this is the point. Okay. Do not use superposition for power calculations directly. Alright, we'll look at one more example. Okay guys, there is the question. So this box, it is what? Having only resistors. So this box, it is said that it is having what? Only resistors. And then this, so because it is what? Having only resistors, definitely it is what? A linear network. And how many sources are, or how many independent sources are driving this network? Three different independent sources. One current source, one voltage source, and also another voltage source, IA, VB, and VC. And what is the quantity of interest? It is the current flowing in this particular branch. That is what I naught. So this is like one input. There is like another input, or let me call the input as what? X1. So there is like X2, there is like X3, and this I naught, it is the output quantity of interest. So it is like the output. Okay. And because it's a linear circuit, so definitely I naught will be equal to what? Something times X1, which is IA, plus something times X2, which is VB, plus something times X3, which is VC. And here a table is given. Yes, there are three different cases. In each case, some sources are on and the other sources are off, and the value of I naught is also given for each and every case. Okay. Now the question is what this? Please read the equation carefully. Find I naught, that is what? The same output. If IA and VC, if IA and VC are doubled, and VB is what? Reversed. IA and VC are doubled, that means what? IA becomes 2 IA, VC becomes 2 VC, and your VB, it becomes what? Like minus VB. You understood, right? So in other words, X1 becomes what? 2 X1, X2 becomes 2, X2 becomes minus X2, and X3 becomes what? 2 X3. Then what does the output become? Okay, that is the question. I hope you have understood the equation. So this is completely based on the linearity of the circuit. So what is the property of a linear circuit? Output will be what? A linear combination of the various inputs. Okay. So I'll just clear off this entire thing. let's say I naught due to IA alone is what, some A. That means what, in this circuit, if only the current source IA is present, if the other two sources are not present or made 0, then there will be some value of I naught, right? That value of I naught, we'll call it what, A. And let us say I naught due to the voltage source VB alone, let it be some B. That means in this circuit, if only the voltage source VB is present, then there will be some value of I naught. Let that value be B. And then let's say I naught due to VC alone is what, some C. Okay. If only the voltage source VC is present, the value of I naught will be what, some C. Okay. Now look at the first case. In the first case, IA is present, VB is present, but VC is not present. Off means what? Not present. On means what? It is active or present. It is active or present. Okay. So due to IA, you will get what? A. Due to VB, you will get what? B. And because VC is off, you won't get any C. So what is this 20 amps? Is it not A plus B? And then look at the second case. In the second case, IA is present, VC is present. Due to IA, you will get what? A. Due to VC, you will get what? C. When both IA and VC are present, you will get A plus C. And in the third case, all three sources are active. So whatever value of I naught that you get, it is what? A plus B plus C. You understood? Yes. So we have three unknowns. We also have three equations. A plus B is 20. A plus C is what? Minus 5. And then A plus B plus C is what? 12. I think from these three equations, we can easily find the values of A, B and C. A plus B is what? 20. So in place of A plus B, if you write 20, 12 equal to what? 20 plus C. So C is what? I think minus 8 amps. Okay, if C is minus 8, then A will be what? 8 minus 5. I think A will be what? Like plus 3 amps. If A is 3, A plus B is 20. So I think B will be what? Plus 17 amps. So these are the values of A, B and C. I hope you also got the same three values. Now let us answer the actual question. Okay. When IA is doubled, yes, due to IA you are getting what? A. Yes or no? So I naught new, I'll call it the new value of I naught. You see, due to IA you are getting what? A. Due to 2IA you will get what? 2A. Due to VC you are getting what? C. And if VC is doubled, due to 2VC you will get what? 2C. Due to VB you are getting what? B. Due to minus VB you will get what? Minus B. That's all. There is the answer. 2A plus 2C minus B. 2A means what? 6. 2C means what? I think minus 16. And then minus B. B is 17. So minus B is what? Minus 17. So the final value is what? Minus 27 amps. This is the new value of I naught when IA and VC are doubled and VB is what? Reversed. Reversing means what? Multiplying VB with minus 1. Then the corresponding output also becomes multiplied with or gets multiplied with minus 1. Okay. So if any input is what? Scaled by some factor, the corresponding output also gets scaled by the same factor. That is the logic behind this problem. Okay. So this is about linearity and superposition. Now let us quickly talk a little bit about the two types of sources, okay, the two independent sources, voltage sources and current sources. So ideal and non-ideal slash real sources, okay. How would you describe this box? Look at this box. What is inside the box? Just a voltage source. So this is what? An ideal voltage source. Let's say across this ideal voltage source, you connect some, load resistance. Let's say the load voltage what VL and the load current is what some IL. Now because the load resistance is directly connected across what the voltage source, so always the load resistance and the voltage source will be in parallel. Of course here these two are in series as well. In parallel voltage drop will be same for both the elements. So whatever be the value of RL, the load voltage will always be equal to what? The source voltage. Yes. So VL equal to VS. For any value of RL. Yes, on across this voltage source, whether you connect 1 ohm or 100 ohms or 100 kilo ohms or 100 mega ohms, always load voltage will be equal to what? Vs. So this is what? An ideal voltage source. Now if I ask you what kind of source is this green color box, look at the green color box. This time also inside the box we have what? A voltage source. Earlier inside the box we just had the voltage source, nothing else. But this time inside the box we have what? A voltage source and also a resistance in series. So this RS, it is what? The internal resistance of this voltage source, and this is what? This is also voltage source, but this should be called as what? A real voltage source. Real voltage source. So across this also, let us try to connect a load resistance. So the load voltage will be what? Some VL, and the load current will be what? Some IL. Now this load current, is it not the loop current? Yes or no? So IL will be equal to what? Vs upon RS plus RL. In fact here the load resistance and the internal resistance or the source resistance both are in series across what? The voltage source Vs. So voltage division will take place. So VL equal to what? Vs times which voltage is getting divided, it is what? Vs. VL is what? Drop across RL. So Vs times RL upon RL plus RS. So earlier when the load resistance is connected across what? An ideal voltage source, the load voltage is always equal to what? Vs, no matter what the value of RL is. So in other words, in the previous case, the load voltage is independent of the load resistance when the load is what? Connected across ideal voltage source. But this time when the same load is connected across what? A non-ideal voltage source, then the load voltage clearly depends on the load resistance. Previously load voltage independent of load resistance. This time the load voltage, it actually depends on the load resistance. That is the difference between an ideal and a non-ideal voltage source. Okay, and always the load voltage will be less than the source voltage. Previous case always load voltage is equal to what? Source voltage. Why? Because in the second case when you connect the load will draw some current, right? Yes or no? The load will draw some current, and the same current also flows through what? The internal resistance, resulting in a voltage drop across the internal resistance. So whatever voltage you get across the load, it is actually what? The source voltage minus the drop across the internal resistance. In fact, VL can be written as what? The source voltage minus the drop across the internal resistance, which is IL times RS. Yes or no? The load current is what? This. Okay. Here we can also define something called VOC. So what is VOC? It is the load voltage when the load becomes open. So when will the load become open? When the load resistance value will tend to what? Infinity. Yes, on RL tends to infinity, then the load becomes what? Open. When the load becomes open, what is the current in the circuit? The loop becomes open, then the loop current will become what? Zero. If the loop current is zero, then the drop across the internal resistance would be zero. Then this entire voltage Vs will drop across this open circuit. Yes or no? So then it'll be equal to what? Vs. So when will the load voltage be equal to source voltage in the second case? Only when the load is what? Open. But if the load is what? A finite resistance, then always the load voltage will be what? Less than the source voltage, because if the load is what? Finite, the load will draw some current. That current will flow through what? Internal resistance, resulting in a drop across the internal resistance, and the net voltage across the load will be what? Source voltage minus the drop across internal resistance. So the load voltage will be equal to source voltage only when the load is what? Open. Okay. So when does the non-ideal voltage source become an ideal voltage source? Is it not when the internal resistance is what? Zero? Yes or no? When RS is zero, the voltage source will become what? Ideal. So for ideal voltage source, we can say the internal resistance is what? Zero. Again, these things are very basic things. Most of you must be already knowing this. Okay. So here we have seen what? The ideal and the non-ideal voltage source. Let us quickly look at the other source, that is what? The current source. Okay. So if I ask you what is this box, you should say it is what? An ideal current source, because inside the box all we have is what? Just the current source. So this is what? The ideal current source. And let's say across this ideal current source, I connect some load resistance. Let's say the load current is what? IL. Yes. And the load voltage, let it be some VL. Okay. Now in this particular case, the load resistance, it is connected directly in series with the current source. Any elements any two elements in series will always have what? The same current. So here the load current will be equal to what? Source current for any value of RL. Yes or no? Across this ideal current source, whether you connect 1 ohm or 100 ohms or 1000 ohms or 100 kilo ohms, always load current will be equal to what? The source current. IL equal to what? IS. Okay. Let's look at another case. Now look at this green color box on the right hand side. If I ask you what is this box, again it is what? A current source, because inside the box we have what? The same current source IS, but along with the current source, this time we have some resistance in parallel. In fact, this RP is what? The internal resistance of the current source, and because of RP it becomes what? A non-ideal or a real current source. So this is what? A non-ideal current source. Okay. So this is what non-ideal current source because of RP. And earlier we had what RS. Real voltage source will have an internal resistance in series. Real current source will have an internal resistance in parallel. Well, now also across this non-ideal current source, let us connect some load resistance RL. Let the load current be some IL and let the load voltage be some VL. Okay. So this time I will not having the load resistance and the internal resistance both connected in parallel across what the current source IS. So some of this IS will flow through what the load resistance, the internal resistance. The remaining current will flow through what the load resistance. So here current division will take place. Okay. So this IS will get divided between what RP and RL. So easily we can write down IL. Current through RL will be proportional to what RP, right? First you write down the current that is getting divided, that is what IS. So IS times current through RL proportional to what RP upon sum of the two resistors in parallel, RP plus RL. So in the earlier case, the load current is independent of the load resistance, but in this case, clearly the load current depends on the load resistance. That is the difference between an ideal and a non-ideal current source. Ideal current source, load current independent of load resistance. Non-ideal current source, load current depends on load resistance. Okay. Okay. So when will so always load current will be what? Less than the source current. Yes or no? Always the load current will be what? Less than the source current, because some of the source current will flow through the internal resistance. Only the remaining current will flow through what? The load. Yes. So when will the entire source current flow through the load? Is it not when RL becomes short circuit? Yes or no? So here we have something called ISC. Earlier we had what? VOC. So what is VOC? It is what? The load voltage when the load becomes what? An open circuit. This time ISC is what? The load current when the load becomes a short circuit. When does the load become a short circuit? When the load resistance becomes what? 0. You see, when the load becomes a short circuit, then the drop across short circuit is what? 0. Then the drop across RP is also what? 0. Then no current will flow through what? RP. Then the entire current IS will only flow in the short circuit. So what is the value of ISC? It is equal to what? IS. So only when the load is what? A short circuit, the entire source current will flow through the load. For any non-zero value of RL, the always IS will get divided between RP and RL. Okay, that's all. And also for ideal current source, what is the value of internal resistance? Is it not infinite? So when does the green color box become the yellow color box? Is it when RP becomes 0 or infinite? It is when RP becomes open. When you remove RP in the green color box, you will get the yellow color box. How will you remove a resistor? When the resistance becomes what? Infinite. So for ideal current source, the value of RP, that is the internal resistance, is what? Infinite. So for ideal voltage source, the internal resistance is what? 0. Ideal current source, the internal resistance is what? Infinite. Okay. And you also have understood the notion of VOC and ISC. Okay. So let us again go back to what? VOC and ISC. Okay. Let's say this is what? A network. This is what? A network. And across this network, we have connected some load resistance. Okay. And across the load resistance, you will have some voltage drop, that is what? The load voltage. And through the load resistance, some current will flow, that is what? The load current. Okay. So now when I write VOC, it means what? Open circuit voltage across the load. So VOC, it is what? The open circuit voltage across the load. So what is VOC? It is the load voltage when RL tends to what? Infinity. Yes. So what does it look like? So if you have the same network, when the load becomes open, yes, you can simply remove the load. So look at this, load is not there, but across this open circuit you can always have some voltage drop. That is what is called VOC. Okay, and then ISC, it is what? The short circuit current through the load. ISC, it is what? The short circuit current through the load. So it is what? The load current, or the current through the load when RL becomes short circuit. When does RL become short circuit? When the value of RL tends to what? 0. So this time the overall circuit will look like this. Again we have what? The same network, that is what? The box, and outside this network we have connected what? RL. This time this RL will become what? A short circuit, and some current will flow in this short circuit. Whatever current flows in this short circuit in the direction of IL, already the direction of IL is shown here. IL is what? In the downward direction. So whatever current flows in the short circuit in the downward direction, that becomes what? ISC. So these are what? VOC and ISC. I hope these two are clear. So to find VOC, just remove the load, you will get an open circuit. Find the open circuit voltage, that is what? VOC. And to find ISC, replace the load with a short circuit. Find the current flowing in that short circuit, that is what? ISC. So this VOC and ISC are very important quantities. Okay. Now let us look at something called source transformation. So what is that source transformation? You can transform a voltage source into a current source, and also you can transform a current source into a voltage source. Okay, but you should clearly understand under what circumstances one can use source transformation. Okay, you cannot use source transformation just about everywhere. Okay. Source transformation. Listen carefully. Let's say you have what? A real voltage source. What is that real voltage source? Vs in series with Rs. Okay. Yes, on a voltage source in series with a resistance. Okay. And across this I connect what? A load resistance. And what are we interested in? We are interested in the load voltage and also the load current. We are not interested in other things. All we are interested in is what? The load voltage VL and maybe the load current IL. Okay. So there is one source. There is one source. And if you are interested in the load voltage and the load current, that means what? You are not interested in voltage and currents inside this box. So be very clear about this. We are not interested in voltage and current, that is what? V and I, voltage and currents inside the box. We are not interested in voltage and currents inside the box. Okay, we are interested in voltage and currents outside the box. Outside the box, right now we have what? Only the load resistance. So we are interested in what? The load voltage and load current, or maybe the power delivered to the load. If that is the case, you can replace this box with another box. This box contains what? A voltage source in series with resistance. We can replace this box with another box which contains what? A current source in parallel with the same resistance, and the value of the current source is what? The value of the voltage source divided by the resistance in series. So Vs by Rs in parallel with the same resistance. Okay, but once again, outside the box we are going to connect what? The same load resistance RL, across which the load voltage is what? VL, through which the current is what? IL. Okay, so whenever you are not interested in voltage and currents inside this box can be transformed into what? This box. So originally the box contains what? A voltage source in series with resistance, and it has been transformed into what? A current source in parallel with the same resistance. Yes, but in both the cases the load voltage and load current will remain the same. That means what? From load point of view, this white color box is same as what? The yellow color box. Okay, so in both the cases, so the point is what? Let's say this is what? VL1, this is what? IL1, and this is what? VL2, this is what? IL2. Yes, so here VL1 equal to what? VL2. That means in both the cases the load voltage remains the same, even the load current remains the same. So because the voltage and current are same for the load in both the cases, the load cannot really distinguish whether the load is what? Connected across box, the first box, or the yellow color box. So from the load point of view, both the boxes are identical from the load point of view. From the load point of view, both boxes are identical, because in both the cases for the load we are getting what? The same voltage as well as the same current. So load cannot really distinguish whether it is connected across what? The first box or the second box. Okay, so originally we have what? A voltage source in series with resistance, but it has been transformed into what? A current source in parallel with the same resistance. But in both the cases the load voltage and load current are not going to get affected. This is what is source transformation. You can also do it in the reverse direction. You can start with a current source in parallel with resistance, and it can be transformed into what? A voltage source in series with another resistance. Okay, let's say there is what? IS in parallel with RP, and across this we connect some load resistance VL, and let this be IL. Again the point is what? We are not interested in voltage and currents inside the box. We are not interested in voltage and currents inside the box. We are only interested in voltage and currents outside the box. In such a case, you can modify this box. What does this box contain? Actually, current source in parallel with resistance. So this can be modified into what? A voltage source. What is the value of the voltage source? The value of the current source times the resistance in parallel, which is Is times Rp in series with the same resistance Rp. In series with the same resistance Rp. Yes. So the original white color box contains what? Current source in parallel with resistance, which has been modified into what? The yellow color box, which now contains what? A voltage source in series with the resistance, but still outside the box we connect what? The same thing. RL. This is what? The load voltage. This is what? The load current. Now in both the cases, the load voltage and load current will remain the same. That is the whole point. Okay. So this is VL1, this is IL1, this is IL2, this is VL2. VL1 equal to what? VL2. IL1 equal to what? IL2. So in both the cases, the load voltage and the load current are what? The same. So from the load point of view, the original white color box is same as what? The yellow color box. That means current source in parallel with resistance is same as what? Voltage source in series with a resistance. That is purely from the external circuit or the load point of view. Okay, you have to understand this. From the load point of view, again both the boxes are identical. Understood? So from the load point of view, both the boxes are identical. So earlier what did we do? To start with, we had what? A voltage source in series with resistance, which has been transformed into what? A current source in parallel with the resistance. It's the same resistance. This time, to start with, we have what? A current source in parallel with resistance, which has been transformed into what? A voltage source in series with the same resistance. And you can do this source transformation as long as you are not interested in voltage and currents inside this box. If only you are interested in voltage and currents outside the box, then you can always transform the box into what? Another type of source like this. Okay. So let's say you have what? A 10 volt source in series with a 2 ohm resistor connected between what? A and B. And for this, let us try to do source transformation. Yes, so when can you do source transformation? When you are not interested in voltages and currents inside this box, then only you can do what? Source transformation. I'll explain why it is so. Okay. So while doing source transformation, this voltage source will become what? A current source. Yes, when you do source transformation, you will get a current source in parallel with the same 2 ohm resistor. Now you can see the current source and the 2 ohm resistor are connected in parallel across the same 2 points A and B. Yes, so the point is what? The original network is between what? A and B. The modified source is also between what? A and B. That is the point. Now for current source, you will always have what? Direction, right? Now what is the direction? Is it upwards or downwards? Always the direction of the arrow mark of the current source will be from minus to plus. Okay. So for voltage source, you will have what? Polarity, right? Minus, plus. Now the current direction is always from minus to plus. Understood? Or if the voltage source polarity is what? Like this, then the current again will be in the direction of minus to plus. That is what? Like this. So in this case, the original voltage source plus is at the bottom, minus is at the top. So the arrow mark will be in the downward direction, that is from minus to plus. And what is the value of the current source? Value of the voltage source divided by the value of the resistance in series. 10 by 2, it becomes what? 5 amps. So this 10 volts in series with 2 ohms is equivalent to what? 5 amps in parallel with 2 ohms. As long as you are interested in voltage and currents outside this combination. Okay. So this is what an example for source transformation. Okay. So let's say we have what a current source of value 3 amps in parallel with 3 ohms, and we want to do source transformation. So this current source will become what, voltage source of how much value? Current source into resistance, 3 times 3 is what, 9 volts. So 9 volts in series with the same 3 ohm resistor. Even this network is going to be connected between what, the same 2 points A and B. Now for the voltage source, you have to assign what, polarity properly. You should mark plus and minus. Okay. I told you what, arrow mark will always be from minus to plus. Arrow mark upwards, it means what, bottom is minus, top is what, plus. So always be careful about the polarity of the voltage source or the direction of the current source whenever you are doing what, source transformation. Okay. In fact, for a arrow mark, for an arrow mark, this side is called as what, head. This side is called as what, tail. Head is always aligned with the plus terminal or the plus of the voltage, and tail is always aligned with the minus of the voltage drop. Okay. All right. Now the most important point about source transformation. So let's say initially we have what, a 10 volt source in series with a 2 ohm resistor, and then we would like to perform this source transformation. So when you do source transformation, voltage source will become what, a current source. What is the value of the current source? 10 volts by 2 ohms, which is 5 amps. Okay. So it becomes what, a current source of value 5 amps in parallel with what, the same 2 ohm resistor. Even this is connected between what, the same 2 points A and B. So this is what is source transformation. Okay. Now I'll make a statement. Okay. So the original 2 ohm resistor, I'll call it what, R1, and after source transformation we get this same 2 ohm resistor, I'll call it what, R2. Okay, just a second. Now my statement is R1 and R2 are identical. Please comment in the chat box. Is this statement true or false? R1 and R2 are identical. Is this statement true or false? Tell me, whatever statement I just made, is it true or false? R1 and R2 are identical. See, what is R1? 2 ohms. What is R2? That is also 2 ohms. So looks like both are identical, but this statement is what? False. Okay. Please understand that R1 and R2 are not identical. That means this 2 ohm is not the same as this 2 ohm. I repeat, this 2 ohm is not the same as this 2 ohm. I mean, both the resistors have the same value, that is what 2 ohm, but both are not identical. So this statement is false. Okay, so again I will repeat because it is very important. This 2 ohm is not the same as this 2 ohm. Let's understand why. So let's say the original circuit is what this. You have the 10 volt source, you have the 2 ohm resistor, which are connected in series between what? A and B. And let's say outside this some load resistance is connected, and that load resistance let it be some 3 ohms. Okay, so RL equal to what? 3 ohms. What is the load current in this case? See, what is the net resistance in the loop? 2 ohms plus 3 ohms is what? 5 ohms. 10 by 5 is what? 2 amps. So what is the load current? It is what? 2 amps. And what is the power delivered to the load? So PRL is what? I square into R. So 2 square into 3. Yes or no? 2 square into 3, which is 12 watts. So in the original circuit, the load current is what? 2 amperes, and the power delivered to the load is what? 12 watts. Okay. Now when you modify this, this white color box, right now the white color box is what? Voltage source in series with resistance. How do you modify this? We can do source transformation. Okay. So after source transformation, this white color box will become what? 10 volts in series with 2 ohms will become 10 by 2, that is what? 5 amps in parallel with the same 2 ohm resistor. That is what we have drawn earlier as well. So 5 amps in parallel with 2 ohms, again connected across what? The same 2 points A and B. And now also outside this we have what? The same load resistance of value 3 ohms, through which they let the load current be what? IL. Now in the modified circuit, in the second circuit on the right side, are we not having 3 ohm and 2 ohm in parallel across what? 5 amps? Yes. So what is the value of IL going to be? 5 is getting divided between 2 and 3. Current through 3 will be proportional to what? 2. 5 into 2 divided by 2 plus 3, 10 by 5, which is again 2 amps. So what is the power delivered to the load? Again it is what? I square into R, which is 2 square into 3, which is same 12 watts. So in both the cases, for the load resistance, the current and the power are what? Same. That means what? From the load point of view, the white color box is same as what? The yellow color box. This is what? Is source transformation. So this is something we already know. But our statement is what? R1 and R2 are identical. That means what? My question is, this 2 ohm, is it same as this 2 ohm? Yes. What is the power delivered? I mean, what is the power absorbed by this 2 ohm resistor? What is the power absorbed by this 2 ohm resistor? Tell me. What is the current through this 2 ohm resistor? 2 amps. 2 square into 2, which is 8 watts. What is the power absorbed by this 2 ohm resistor? See, already 3 amps is what? 2 amps is what? Flowing through the load. So the remaining current of 3 amps will flow through this 2 ohm resistor. So what is the power dissipated by this 2 ohm resistor? I square into R, 3 square, which is 9. 9 into 2 is what? 18 watts. Now can you understand the difference between the two 2 ohm resistors? In the original circuit, the power dissipated by the 2 ohm resistor is what? 8 watts. But when you do source transformation, the resistance value does not seem to change. It is still what? The same 2 ohm resistor, but the power dissipated by the new 2 ohm resistor is what? 18 watts. So if at all I give you this original circuit and if I ask you to find the power dissipated by this 2 ohm resistor, and if you get tempted to do what? Source transformation, then also it becomes what? It remains as what? The same 2 ohm resistor. But now if you calculate the power for the 2 ohm resistor, it becomes what? 18 watts. Yes, and if you say the answer is what? 18 watts, then your answer is what? Incorrect. So the actual power dissipated by the 2 ohm resistor is what? 8 watts. Okay. So, but for the load, in both the cases, the current, the power, everything is what? Same. So from the load point of view, we can do source transformation. That is not a problem. Okay. So this 2 ohm is not the same as this 2 ohm. Okay. I hope you get the point. Even the power supplied by this 10 volt source will not be same as what power supplied by the 5 ampere current source. So when can we do source transformation? We can do source transformation only if you are interested in voltage and currents outside this box. If you are asked about anything related to within the box, then you should not disturb the box. I repeat, if you are asked about anything related to what, I mean, it can be what voltage or it can be some current or it can be some power absorbed or power supplied, anything related to within the box, then do not touch the box. Do not change the box using what? Source transformation. But if you are asked about anything outside the box, then you can always modify the box using source transformation. I hope I am clear. Yes. That is why earlier also I clearly wrote, for this case I clearly wrote, we are not interested in voltage and currents inside the box, then we can do what? The source transformation. Here also I wrote the same. We are not interested in voltage and currents inside the box, then we can transform this into what? A voltage source in series with the resistance. Okay. So even though the resistance value appears to be what? The same, the two resistors are entirely different. Okay. Yes. So you can do source transformation only when you are interested in voltage and currents outside that combination. Okay. Only when you are interested in voltage and currents outside this combination. Yes. So you can do source transformation only when you are interested in voltage and currents outside this combination. Okay. So let us look at a couple of examples related to what source transformation. Okay guys, look at this circuit. Say some circuit. It contains what? A current source. Yes or no? Current source, then resistor, resistor. This is what? A dependent current source. What is the controlling variable for this? This voltage is the controlling variable for this. And then there is again a current source, resistor. Yes. The question is what? To convert the circuit into what? A single loop circuit. And then you have to find what? Vx. That is the voltage across this 2 ohm resistor. So before you find Vx, you should convert the circuit into what? A single loop circuit. Before you find Vx, you have to convert the circuit into what? A single loop circuit. What is that single loop circuit? Single loop circuit will have what? Only one loop, right? And all elements will be in series around what? That single loop. What is the convenient thing about a single loop circuit? Because all elements will be in series, they'll have what? The same current, that is what? The loop current I, and you can easily write KVL around this loop or the single loop to find the value of the loop current, and from the loop current we can find every branch voltage. Okay, that is the convenient thing about the single loop circuit. The other convenient circuit is what? The single node pair circuit. In a single node pair circuit, all elements will be connected between what? The same two nodes. What is the good thing about the single node pair circuit? All elements will be in parallel. So all elements will have the same voltage drop. So the only thing you have to do is what? To write KVL either at this point or at this point. Then immediately you will find the voltage drop across this pair of nodes, and that is the voltage drop across each element, and from that voltage drop you can find the various branch currents. So it is always convenient if we can simplify complex circuits into what? Either single node pair circuits or single loop circuits, because all we need to do is what? Just one KCL or one KVL. Single node pair, just one KCL. Single loop circuit, just one KVL. Okay. So how do you convert this into a single loop circuit? By doing repeated source transformation. Yes or no? By doing what? Repeated source transformation, you can convert this circuit into a single loop circuit. Okay. Now let us start from the right side. So on the right side, I am not having current source in parallel with resistance, which can be transformed into what? A voltage source in series with the same resistance. Value of the voltage source is what? 5 times 3, that is what? 15 volts in series with 3 ohms. And then we have this 4 ohm resistor. Now 3 ohm and 4 ohm both are in series. You can combine them into what? A single 7 ohm resistor. Okay. Now this 15 volts in series with 7 ohm can again be transformed into what? A current source in parallel with the 7 ohm resistor. What is the value of the current source? It is 15 volts by 7 or 15 by 7 amps. Okay. And then you have this original 7 ohm resistor. So when you add that 7 ohm resistor, now 7 and 7 both are in parallel. 7 parallel 7 can be clubbed into what? A single 3.5 ohm resistor, which can again be transformed into what? So look at this combination. Current source in parallel with resistance can be transformed into what? A voltage source in series with the same resistance. What is the value of the voltage source? Multiply current with resistance. 15 by 7 into 3.5 is what? 7.5 volts in series with 3.5 ohms. So that means what? This entire network is equivalent to what? This 7.5 volts in series with 3.5 ohms. I hope you have understood how by repeated source transmission we have simplified this part of the network into what? A single voltage source in series with a single resistance. Okay. So 7.5 volts in series with 3.5 ohms. Okay, and then please look at this thing. Please look at this thing. What is this thing? Is it not a current source in parallel with a resistance? Of course, it is what? A dependent current source. Dependent current source in parallel with resistance can also be transformed into what? A dependent voltage source. Normally, for independent current source, when you do source transmission, it becomes what? Independent voltage source. But here we have what? A dependent current source. Dependent current source in parallel with resistance will become what? A dependent voltage source in series with the same resistance. Okay. If you call this A, if you call this B. Now original circuit, the current source and the 17 ohm resistor both are in parallel between what? Like A and B. Now when you do source transmission, it becomes what? A dependent voltage source in series with 17 ohms also between what? A and B. So if this is what? Like A, and if this is what? Like B, so it becomes what? A dependent voltage source. What is the value of the dependent voltage source? Current source into resistance, right? 3Vx into 17 is what? 51 Vx. Now what is the polarity of the voltage source? Arrow mark is from left to right. Arrow mark will always be from, minus to plus. So this is minus, this is what? Plus. Okay. And now the 17 ohm resistor, now the 17 ohm resistor will be in series. Now also the voltage source and the 17 ohm resistor both are connected between what? The same 2 points A and B. Originally both were in parallel between A and B. Now both are in series between what? A and B. So in this way we can also do source transmission even for dependent sources. Okay. So I'll just remove this. So far so good. And then we have what? The 2 ohm resistor. So this 2 ohm resistor, I'll draw it as it is. And remember, you should not touch this 2 ohm resistor. Why? Because when I say don't touch, it means what? This 2 ohm resistor should not be involved in any kind of source transmission or even any kind of series or parallel simplification, because the drop across 2 ohms is what? The controlling variable for this dependent source. Understood, right? Because the drop across 2 ohms is what? The controlling variable for this dependent source. Do not touch the 2 ohm resistor. Let the 2 ohm always remain as what? The same 2 ohm resistor. Okay. And then finally we have this thing. What is this thing? Current source in parallel with resistance can be transformed into what? Voltage source in series with the same resistance. What is the value of the resulting voltage source? 1 ampere into 9 ohms is what? 9 volts in series with 9 ohm resistor. Okay. So this is what? The 9 ohm resistor, and then this is what? The 9 volt source. That's all. Now if you look at the circuit, is it not a proper single loop circuit? All elements are in series around what? A single loop. Okay. So by doing repeated source transmission, we are able to convert the circuit into what? A single loop circuit. Now all we need to do is what? Write one KVL around this single loop. Okay. So how do you write KVL? You have to assume some loop current I. Okay. So here if you want, you can further do some simplification. Okay. the two voltage sources, are they not in series? Yes or no? 9 volt and 7.5 both are in series. When voltage sources are in series, you can combine them into what? A single voltage source. Yes or no? Now these two voltage sources should be added or subtracted. Minus of this is connected to what? Minus of this you have to subtract. Always subtract small from large, 7.5 from 9. 9 minus 7.5 is what? 1.5. So if you want, you can replace the two voltage sources with a single voltage source. In fact, this 9 volt will become what? 1.5 volt, and the 7.5 will become what? A short circuit. Okay. And also you can combine the resistors 3.5, 17 and 9. See, technically, I mean 3.5, 17, 2, 9, all four are in series, but I already said do not touch the 2 ohm resistor, because if you combine the 2 ohm resistor, then Vx will disappear, and Vx is what? The controlling variable for this. So apart from the 2 ohm, the rest of the 3 resistors can be combined into what? A single resistor. 3.5 in series with 17 is what? 20.5. In series with 9 is what? 29.5. So 29.5 ohms in series with 51 Vx in series with the original 2 ohm resistor, across which the voltage drop is what? Vx. See here, in fact, you should not touch Vx for two reasons. Okay. Number one, because Vx is what? The controlling variable for this dependent source. The other reason is what? The question is what? To find Vx. Whenever you are asked to find Vx, Vx is what? Drop across 2 ohm. Do not touch the 2 ohm. Okay. So don't touch Vx for two reasons. Okay. Because, I mean, don't touch this 2 ohm resistor for two reasons. Because the drop across 2 ohms is what? The controlling variable. Not only that, the drop across 2 ohms is what? The final value of interest. Okay. Anyway, so this is what? The 2 ohm resistor. And as I said, the 9 volt and 7.5 volt sources can be combined into what? A single 1.5 volt source. Okay. That's all. This is the maximum simplification that can be done in this circuit. Again, the loop current, let it be some I. Let us write KVL around this loop starting from this point. So 29.5 I minus 51 Vx plus Vx plus 1.5 equal to what? 0. Yes. But what is Vx? It is what? 2I. Okay. Vx is what? 2I. So minus 51 plus Vx is what? I mean, minus 51 plus 1 is what? Minus 50. And Vx is what? 2I. So 29.5I minus I think 100I plus 1.5 equal to what? 0. So from here we can find the value of I. I think the value of I would be 1.5 upon what is 100 minus 29.5? 70.5. So this is what? The value of I. Okay. But the question is what? To find the value of Vx, which is 2I, which is 3 by 70.5. That is the value of Vx. Okay. 3 divided by 70.5. Is it correct? 0.042 volts. 0.042 volts. This is the value of Vx. Okay. So this is how we can use what? Source transformation to make our life easier. So here, because I am explaining the analysis, it is taking this much time. Otherwise, it won't take that much time. Okay. So that is what? The value of Vx. So you can do source transformation when you are interested in voltage and currents outside this combination. I'll add to this point. if the voltage or current through an element is the controlling, I think earlier also I made this point, I'll just repeat it, okay. So the voltage or current through an element is the controlling variable for some dependent source, then do not involve that element in any kind of simplification. Like series or parallel or even source transformation. Understood? Okay. And if the voltage or current through an element is the final value of interest, then again do not involve that element in any kind of simplification. Understood? Yes. So this is everything that you should know about what source transformation. Okay, look at this question. So there is some circuit and the question is what to find Vx, okay. Say on the left hand side, I mean you can use any method of your choice, but I'll just do it my way. Say on the left hand side we have what? A current source in parallel with resistance. Can we do a source transformation for this? You can, but you should not. Why? Because the current through 20 ohms is what the controlling variable for this. You should not do source transformation. Okay, I hope this is clear. Okay. And then on the right side, we have this combination, right? Dependent current source in parallel with resistance. Can we do a source transformation for this? Yes, I mean, generally we can do source transformation, right? We can transform this into what? A dependent voltage source in series with a resistance. But here again, you should not do source transformation because what is the equation? It is to find Vx. So the drop across 30 ohms is what? The final value of interest. Again, you should not do source transformation. Okay. And then we have another combination, which is what this. Look at this thing. Can we do source transformation for this? We can. I mean, what is this combination? Voltage source in series with a current source, which can be transformed into a current source in parallel with the same resistance. Because, I mean, we are not interested in voltage or current in this combination, and also no voltage or current in this combination is the controlling variable for some other dependent source. We can definitely do source transformation for this. So for this, you should not, for this also you should not, only for this, you can do source transformation if you want to do, okay. Okay. So, (4 amps in parallel with 20 ohms, and the current through 20 is what I. And then let us do source transformation for this. It will become what, 60 by 10, 6 amps in parallel with 10 ohms, and the direction of the current will be from minus to plus, that is what, in this direction. Okay, so this is what, 6 amps in parallel with 10 ohms, and this is what, the original 30 ohm resistor, across which the voltage drop is what, Vx. And then we have this .4 I. Okay, so the original circuit can be modified like this. Now we'll try to find Vx. You can find Vx in multiple ways, but let us do nodal analysis. So in nodal analysis, we have to identify all the nodes. This is what, one node, this is what, another node, this entire thing at the bottom is what, another node. So 3 nodes, one node will become what, ground. Let's say this node is what, ground. Okay, and what is this drop? It is what, 20 I. Now this ground or zero potential, you go from minus to plus at the drop. So what is the voltage at this point? It is what, 20 I. It is what, 20 I. Yes or no? So the 20 I minus 0, the drop is what, 20 I. Now this is 0, you go from minus to plus at the drop. So what is the voltage at this point? It is what, Vx. Okay, so how many unknowns we have? 2 unknowns, Vx and I. So we can write KCL at this node and also KCL at this node. Okay, so 4 amps is what, entering, I is what, leaving, 6 is what, leaving, this current is also what, leaving. So what is KCL at this node? Let me call this node A. So what is KCL at node A? I think I plus 20I minus Vx by 10 plus 6 equal to what, 4. So this is going to be our first equation. Understood? And then we have to write a similar KCL equation at the other node. Let me call this node B. What is this current? Vx by 30. What is this current? 0.4 I. And what is this current? It is 6. What is this current? Vx minus 20I by 10. Okay. Now at point B or node B, this current is entering, this current is leaving, this current is leaving, this current is what, entering. 2 are entering, 2 are leaving. So 6 plus 0.4 I equal to what? Vx minus 20I by 10 plus Vx by 30. That's all. So here we have what, 2 equations, and also we have 2 variables. From these 2 equations, you can eliminate I and find Vx. Okay. So find Vx. When you try to find Vx, the value of Vx will be this much, 82.5 volts. That is the value of Vx. Okay. So again, why did I take up this example? So this is just to caution you under what conditions we cannot use source transformation. So for this, you cannot do source transformation. For this also, we cannot do source transformation. We can do only for this combination. What is it? Source transformation. Okay. Okay guys, look at the next circuit. So there is some circuit, find the value of K. Where is K? K is what? In the value of the dependent voltage source, K Vx. Find the value of K for which Vy is what? 0. Vy means what? The voltage drop across the 2 ampere current source. So here Vy becomes what? 0. Okay. So for Vy to be 0, what is the value of K? That is the equation. Now in this circuit, is there a ground? There is no ground, right? In this circuit, there is no ground. In any circuit, if there is no ground, you can choose any node to be ground. Just for convenience, I will choose the bottom node to be what? Ground. And because Vy is what? 0, this is 0, Vy is 0, the voltage at this point is what? 0. Now this is what? 0, you go from minus to plus, the voltage at this point is what? Vx. Now this is 0, you go from minus to plus, add the drop, so the voltage at this point is what? 6 volts. Now this is again 0, you go from minus to plus, add the drop, so the voltage at this point is what? K Vx. Okay. Now what is this current? 6 minus Vx by 1. What is this current? Vx by 4. What is this current? Vx minus 0 by 2. So can't we write KCL at this point? So at this point, two currents are leaving, one current is what? Entering. So 6 minus Vx by 1 equal to what? Vx by 4 plus Vx by 2. So 6 minus Vx equal to what? I think 1 by 4 plus 1 by 2 is what? 3 by 4. 3 Vx by 4. And from here, Vx will be what? What is 1 plus 3 by 4? 1 plus 3 by 4 is what? 7 by 4. So Vx will be what? 6 into 4 by 7. So this is what? Vx. 24 by 7 volts. That is what? The value of Vx. But the question is what? To find the value of K. Okay. Now, what is this current? KVx minus 0 by 3. See, even though the drop across the 2 ampere current source is what? 0, still the current in this branch will be equal to what? 2 ampere. So what is this current? It is what? 2 amps. Okay. And then what is this current? Vx minus 0 by 2. Now at this point, can't we write KCL? This current is entering, 2 is entering, this current is also what? Entering. So what is KCL at this point? Vx by 2 plus K Vx minus 0 by 3 plus 2 equal to what? 0. Okay. That's all. So Vx times 1 by 2 plus K by 3 equal to what? Minus 2. Yes. So 1 by 2 plus K by 3 is equal to what? Minus 2 times. Vx is what? 24 by 7. So minus 2 into 7 by 24. I hope I have not made any mistake. Yes. No, I think I made a mistake. Sorry. 6 minus Vx. No, it is correct. Yeah, it is correct. Okay. Let's see. So what is this? Minus 14 by 24. So what is K by 3 then? Minus 14 by 24 and then minus half. So when you take LCM, I think you'll get minus 14 plus 12 is what? 26 by 24. This is what? K by 3. So K is what? Like minus 26 by 8. I'm getting this. Maybe it is incorrect, but I hope you have understood the procedure. Okay. So what is 26 by 8? 26 by 8. Okay, 3.25. So the final answer is what? minus 3.25. That is the value of K. Is it clear? So here, because there is no ground, I have chosen some node to be ground so that the analysis becomes easier. Once I choose this to be ground, then I try to write voltages at as many nodes as possible, and then I always write what KCL. So this is how I do what circuit analysis. You should also try to do it using the same approach. Okay. So this completes what? Linearity and superposition, and also source transformation. So I'll end the session for now. In the next session, we will look at other important circuit theorems. Okay.